The statistics for data science, module 1. Overview of statistics. So, if you look at the statistics as a field, they broadly can be classified into two categories. One is descriptive statistics, other one is inferential statistics. Descriptive statistics is mostly for describing the data. So, for example, you're looking at a sales of a business. So, let's say last financial year sales. So what you do, you take a sum of it, and you also create average sales per customer, and you categorize it into different regions or maybe different products or categories, product categories. You take several means, and all of these visualizations, all of this comes under descriptive statistics. In simple words, descriptive statistics is presenting the data in an informative manner. So we actually take 100% of the data and we present that in an informative manner with reports, summaries, visualizations, graphs, and dashboards, etc. So this is actually called as descriptive statistics. A second broad area is called as inferential statistics, where we don't deal with the entire data, because most of the time you go for inferential if you don't have access to the entire data, or it's difficult to get this entire data. You rather work with a sample which is a subset of the data. The simple example we could discuss about, we could take in this is your exit polls in political elections. So you have elections, before elections you have these exit polls, and this exit polls comes up with the prediction or forecast, analysis of the which party will be getting what kind of positions in the election. This is a very good example for your inferential statistics. Okay. So let's get into more details about different terminologies in statistics. Okay. So first one is population. So take the exit poll example itself. So exit polls is a good example. So let's say you're doing a election. India has about 1.3 billion population, and you would like to take a sample. Of course, for finding a sample size, you have something called as Cochran's formula, and there are other methodologies to find a sample size, or I would say minimum sample size. Right below that, it may not be a valid sample. But roughly, I'm going to take, let's say, we're going to talk to 20,000 people across India in various different regions, very different categories, and try to know which party they are preferring and why, and accordingly we'll make a forecast on the election polls. All right. This the complete data, which is 1.3 billion population in India, is called as population. I already said population because it's called as population. Whereas this, a subset of your population taken from it, is called as sample. So population is 100% data, and sample is a subset of the population, which could be based on the data itself. How much percentage? There are methods to find what's the minimum size of sample, which we'll discuss later. And then you have another terminology called variable. Variable means, so I'll take an example. So let's say you are doing a survey. Okay. You're doing a survey. Um, Let the survey be how safe are the uh, women in India. So let's take a city. So I'm currently in Bengaluru. So I'll say city of Bengaluru. What's the women's safety perception? So I want to do a survey of women's safety perception. It's always perception, it's relative. Okay. All right. So to do that, so I need to really first of all know my population. So let's say the people who fall under this category is about 30 lakhs. 30 lakhs is 300,000. And then our sample size, I'm going to take 3,000, the sample size. Okay, roughly I'm taking right now. And so basically, I need to pick 3,000 people from this 300,000 population and then ask few questions about the women's safety. So what kind of questions you ask? Let's say I'm going to ask something about the age is primary thing, of course, and are you working, and of course, are you married? Does have an effect on your perception on safety, uh, and many other things. For example, your education, and all of these are typically we call it as respondent demographics. These variables are called as respondent demographics. So demographics is basically talking about the respondent itself, information about the respondent. And then we go to the variables which is more related to our survey, like how do you rate the safety perception uh, in the scale of 1 to 10. Safety, how do you rate it? That's a straightforward question. We can ask more questions. Do you feel comfortable going out alone in late nights? All right. Or do you heard any late night is okay? So do you heard any incidences or you ever past 6 months about regarding women's safety? So any incidents and many other questions related to that. These are specific to the survey we are doing. And all of these are called as variables. So these are actually variables. All of these are called as variables. The variables are basically the fields we would like to gather the data. We would like to gather the data for. Based on that, we can do our analysis. So that's your variables. And then you have data. So well, if you go ahead and collect the data, so let's say there is a woman of 30 years of age, working, yes, married, yes, education, let's say graduation, and we can also take salary levels and stuff to see. Or maybe you should actually put economical class, it's rich, poor, middle class, because that really determines your safety factor as well. So I could also put some skills, just for example. Let me put not able to arise. Okay, so no problem. So I'm going to say skills, maybe skills. Okay, skills, and then something related to the incidences. So skills, maybe she is a software engineer. People can also have multiple skills, right? So maybe she is also a, I don't know, she is an accountant. She is an accountant as well, or she knows accounting. Or maybe you can have another lady who is like 35 years, also working, married, education, post-graduation. She is a, let's say, a doctor, and also let's say a singer, a professional singer, a fine artist, okay? And maybe she rates something here, and no, something like this, okay? So what we collect the data, as I said already, data is called as data, and these are all actually singular data. It's called as singular data. Singular data means it can have only one value. So obviously age is singular data because you can have only one age. Also, are you working? Yes or no. It's a singular data, either yes or no. So these are all singular data. But data like your skills, you can have multiple values. So you can be a doctor, you can be a singer, you can be also something. So there are plural data. So two terminologies mentioned over here: singular data and then plural data. And the other one is your experiment. Experiment, let's say, I'm going to keep this for the future reference. Take a new slide. Okay. Let's say there is an energy drink. Energy drink, children energy drink. children energy drink. So I'm going to say ABC. I'm not going to take any brand name. So ABC energy drink, okay. And I want to test whether this drink really, say, they're claiming that if the children have this, like, take this energy drink, so they'll actually grow, let's say, 20% taller, and their bones will be, I don't know, 30% stronger, something like this, right? So I want to statistically check this. For that, I need data. So how do you collect the data? Well, I could get some 50 kids, 50 kids of the age group which is targeted for this energy drink, and then I divide them into two groups, 25, 25. Okay, and then of course, before dividing, I'll measure all of these kids parameters like their height, weight, other bone density, and other related parameters which I would like to measure, and then give this one group of the people only milk, for example, another group milk with this ABC energy formula drink. Okay, after maybe a month or two, based on how much experiment actually makes sense, then you after 2 months you basically collect the same parameters like your height and weight and other all the parameters which you collected before. Now you compare these two parameters, then decide on an average if this group ABC energy drink formula group is actually grown 20% and have more stronger bones and etc., etc. This entire setup is called as experiment. So I could simply say experiment is a mode of collecting the data uh, for our statistical study. In this case, my study is about to really say whether the drink is affecting the children health, growth, and bone density and other parameters what they claim or not. For this study, I want to collect the data, then I take a channel, the way of experiment. The experiment is the way you actually collect the data. So if you can see, experiment is a planned activity, also constrained activity, controlled activity, whose results yield a set of data. That's your experiment. And then you have two more basic terms in statistics we often use, parameter and statistic. Look at the parameter. So in the previous example, we have this, let's say, we have this women safety perception survey study, I would say, study, and of which we had 30 lakh population. So 30 lakh population or 300,000 population, and the sample size is 3,000. All right. So if you take an average of the age of this 3,000 population, it might be actually something like 28, and our sample actually got 26 years, because sample is a subset. Obviously there will be some differences, right? And then let's say how much percentage people, this is age, how much percentage of people are married in the population. We can only estimate because population is a bigger, we don't have all the data. So let's say out of which about 35% people are actually married, and in your sample it only came to be 30% people are married. Maybe you are talking to more younger, your sample got more younger women who are not married. So there's a difference between population and sample. The parameters or the values, the summary of the values which belong to the population are called as parameter. This is parameter, okay? And the one which belongs to sample, I mean with summary of it, like 26 and 28, 30%, 26, these are all your statistic. Statistic is a summary of a variable of a sample data, and the parameter is a summary of a variable of your population. So that's the difference. Whenever you say, when you see parameter, so you're talking about a population variable summary. And statistic without yes, because statistics becomes a domain, the field of study. Statistic refers to a summary of a variable of sample data. Okay. So that is all the basic terminologies, and of course, there are two kinds of populations which I did not mention: finite, infinite. But in data science, we are usually concerned about finite. Finite is the one you can measure. Infinite population is something like your grains in the beach, the sand in the beach sand. These are all infinite, which you cannot count. But with respect to data science, we are always concerned about the finite population. So we don't have to worry about infinite population related statistics. All right, so going to the next slide. Same thing explained in more graphical way. Okay, this is an important slide. It talks about types of data. There are two types of data broadly, with numerical and categorical. So let me take a snap of this one. It's more easier for me in my. Okay. 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 So numerical data and categorical data. Numerical data is also called as quantitative data. Quantitative data, just a different name. And categorical is called as qualitative data. Okay. So as the name indicates, categorical or qualitative data talks about the quality of a particular aspect or particular um, entity you are talking about. For example, gender. The gender is a quality of a person, male or female, or the two valid entries for it. So they're talking about the quality, and it's also called as categorical because basically, if you take gender, male and female, it's dividing the data into two different categories. So categorical data or qualitative data means it's basically qualitative data. It talks about the quality of a particular aspect. Other examples include your eye color, blood group type, ethnicity, your dog breed, for example, or vehicle brand you are driving. All of these comes under categorical data. The other side is numerical data, also called as quantitative data. And this is actually the data which represents the quantity of a variable. For example, sales. Sales is a quantity. So how much sales you have made last year or last month, last quarter. So how much sales? So you're talking about the quantity of the data, right? So it's easy to actually, for example, this can be quickly checked. Quantitative data typically gets you an answer for how many or how much. If you ask this question, you get a sensible answer, meaningful answer, then it's quantitative data. If not, it's probably qualitative data. Other example of your quantitative data is your weight. The weight is how many kgs this weigh, or how many kgs are you, your weight is. So this is how many is quantity. All right. Other examples include your age. How many years are you old? So how many, it's quantity. So that's your quantitative data. That's a high level classification of quantitative and qualitative data. It has further classified into more subcategories. So before going there, let's try a quick slide which basically classifies the data into qualitative and quantitative. All right. So here it's given as qualitative and numerical. So numerical is nothing but your quantitative. Qualitative is also called as categorical. So I'll stick to the categorical and numerical convention. Okay, I'll just leave this away. Categorical and numerical convention. So look at the board. Temperature in Barrow, Alaska at 12 p.m. on any given day. So that's the first question. Is it categorical or numerical? Temperature in Barrow, Alaska. So when you say temperature, how much is the temperature? So it's actually talking about the temperature as a measure. It's a quantity. It is a numerical data. Okay. The second question is that the make of automobile driven by each faculty member. The make of automobile driven by each faculty member. So it could be a different car brands, all right. It could be Benz, Mercedes-Benz, BMW, Tata. So these are different brands. So you are actually categorizing the data, and it's actually talking about which brand it is as a quality. So it is not a quantitative, it's a categorical variable. And then you have whether or not a 6-volt London battery is defective. So defective, not defective, again comes under qualitative data. So it is qualitative or simply categorical. Weight of a lead pencil. So when you say lead pencil, weight of a lead pencil, anytime you see weight is always quantitative, because how heavy, how many kgs, how many grams, whatever it is. A weight of a lead pencil is of course numerical data or quantitative data. The length of a time billed for a long distance telephone call, so you're talking about duration, how many hours, how many minutes, so how many, it's a numerical data. The brand of a cereal children eat for breakfast, so different brands, it is a qualitative data, or simply in this case it's categorical. A book, the type of book taken out of the library by an adult, doesn't matter whether it's adult or child, talking about type of book, it's a categorical data. It's very important to recognize whether the data you have is categorical and numerical, because a lot of things depends on it, from the data processing, identifying, even the filling the missing values, to the type of treatment you do in terms of scaling and other processes in your data processing. Also, even the selection of your machine learning algorithm or the optimization of algorithm depends on what kind of data you have. So identifying the data, whether it's numerical or categorical, is foremost important. Okay, let's go back to our same diagram where you have further details about the subcategories of the data. Quantitative data, so we'll start with qualitative. Qualitative or categorical data is further subdivided into nominal and ordinal data. Okay, nominal, you can simply say it is nominal is no order. No order is nominal. So the data which does not have an order. Simple example is your gender itself. So you say gender of male and female, no order. It's very controversial, isn't it? So no order. You cannot say one is better than other. So there is, at least in the data, it's male and female, no order, it's categorical. So let's take an example of your blood group. There are different blood groups, A positive, B positive, AB positive, AB negative, O positive, O negative. So these are different blood groups. As such, blood group has no order. So it is a nominal data. The other subcategory of your categorical data is ordinal, or simply say it is ordered nominal, it has an order. Typical example is customer satisfaction. So customer satisfaction, you give 5 stars or 1 star. Okay, so 5 star is that you basically have 5, 4, 3, 2, 1. They are categories of your satisfaction. 5 is great, 1 is worst. All right, and they do have an order because 5 is an excellent service or a product, and 1 is a worst product or a service, worst experience. So it's an ordinal data. So another example could be a pain severity. If you go to hospital, your doctor might put you a pain severity in the scale of 1 to 10. 1 is a mild pain, 10 is a very severe pain, right? And there are 1 to 10 range, which have different pain scale. So based on your, his assessment and your inputs, he actually puts a number of pain severity. Accordingly, he will prescribe some medicines for you, drugs for you. This is categorical because you're categorizing the pain into 10 different categories, and it is ordinal because it has an order. 10 is a very severe pain, and 1 being mild pain, or pain you just feel it, but it's not. So these kinds which has an order, categorical but has an order, is called as ordered nominal or simply ordinal data. Okay. It's easy to remember because nominal starts with nominal, so it is no order. Ordinal starts with ordinal, it is order. So it's easy to remember. We will get back to more examples on this. Let's go to the second one, which is numerical data. Numerical data has again two subcategories. One is actually called as discrete. It's also called as interval. Interval or discrete are one and the same. It's the same term, no, same thing. It's used in different places, used different way. The same word representing the same data. Discrete or interval means it is quantity, which means you're measuring, but they don't have all the values. For example, let's take a simple example given over here, shoe size. If you have a shoe size, you might have a size like 6 is one size, 7 is one size, 8 is one size, 9 and maybe something like that. So if you go to a shop and if I go to a shop and ask, I want a shoe size of, let's say, 7.65. Does it make any sense? You don't have a size of 7.65 because that is an invalid data for shoe size. Shoe size has a predetermined interval values. So only those data or those values make sense for the shoe size. And this kind of thing is called as discrete data because it only assumes a discrete values. It's also called as interval for the same purpose, for the same meaning. So that's your discrete. It is still talking about the quantity, how, is it 6 feet or 7 feet, inches, I don't know, inches and 8 inches. So this is actually a measurement of your feet, okay, but it doesn't have all the values, so it becomes discrete. The last one is of course continuous. Continuous, or it's also called as ratio data. So another name for continuous is ratio data. It assumes all the values in a number scale. For example, your weight, I can say 70.123 kgs. It's perfectly fine because I have a precision meter. I can even go more decimals. In fact, in any two given number, you can have infinite numbers in between because you can have any number of decimals or any number of precision. So it's a continuous data, means it can have any value in a given scale. Those kind of data is called as continuous. Typical example, your age, weight, sales, blood pressure, all of these things comes under continuous. So your categorical data is divided into nominal, ordinal. Nominal, no order. Ordinal has order, and they are categorical. Numerical data talks about the quantity of the aspect, and it has discrete, which can have only one certain predefined discrete values, and continuous can assume all the values in the scale. Let's go back to the slide and try a few questions. So these are questions, and just read it out. First question, length of time until a pain reliever begins to work. So it's a duration you're talking about. Duration is of course continuous. It is continuous because it can have any length, it can have anything. I can say it takes 10 minutes, 45 seconds. That makes sense. I can even go further, more decimals, it still makes sense. Number of, the second one, the number of chocolate chips in a cookie. This is number of chocolate chips. You're talking about number of, it's obviously how many cookie chips, how many chips in the cookie, which is quantitative. And then it can only have 1, 2, 3, 4. It cannot have fractions or decimals. It cannot have all the numbers. So it is a discrete data. It is quantitative, but it can have only certain values, which is actually integer values in this case. So it's a discrete data. In fact, as a thumb rule, you can remember anything which says number of, it's usually discrete data. I already said that. So the next question is number of colors used in textbooks. So it is of course discrete data. The brand of refrigerator in a home, you can have any kind of refrigerators, Whirlpool and all kind of brands. So they are like, basically different brands. So it is categorical, does not have any order. I don't see any order. So this is nominal data. Overall satisfaction rating of a new car. Satisfaction rating, so it is categorical, it has an order, satisfaction rating. So it becomes ordinal data. The number of files, when you say number of, it's of course discrete. The pH value of water. pH value can have any decimals in between as well, so it's continuous. And the number of staples, so it is discrete. So you can find more of these questions and practice better because this is very fundamental. So if you look at the data, you should know what kind of data it is. Nominal, ordinal, discrete or continuous. Okay, so these are the operations we perform in different data types. So even before going that, let me just show you one, like take you to the one example uh, of the same type. So age, what is an age? Age is an continuous data, isn't it? Because you can have, as you've seen, but it really doesn't, you can't just hear a field name and say it's continuous discrete. It depends on what kind of data you have. If you have an age like this, let's say 35, I don't know, 26, 28. I can also have decimals, age is 65, 45.5. Age can be like this if I'm giving in more details, okay, and 18, so on and so forth. All right, these are all age, and I can say that this is a continuous data because I have data continuously. Can I make this age into a discrete data? Well, of course you can do it. You have to just define the intervals. For example, so I can simply say I'm going to say any age between 0 to 10. I'm just going to take 5 as the interval. 11 to 12. I think you remember your high school mathematics where you have interval boundaries and mid values. So mid values can be taken as the category. So any age between 11 to 20 can be taken as 15. 21 to 30 can be taken as 25. If you define the intervals as like this, lower boundary and upper boundary, and the mid values become your category. Like 5 means it can have any value between 0 to 10. Okay, no 0, it should be starting with 1. My apologies, because this is 11. So, all right. So this, if you define that, then I can actually convert my continuous data into an interval. Interval is also called as discrete, if you remember. So now this simply becomes 35, this becomes 25, this becomes 25 as well, this becomes 65, this becomes 45, this becomes 15. So I have converted my continuous value into a discrete value. This is actually pretty straightforward, but you lost some information. Your continuous value data has more granular information, exact age of a person or a record. Here we have lost that. In fact, we got a category, which is a range. It's just saying that if you say 25, the value can be anywhere between 21 to 30. So you're losing some information and making it more interval data. The next question, can you make it as a categorical data, which is, let's say, ordinal? Well, you can do that. Just you need to define certain things, like again some rules saying that anyone who is below 20 is called as kids, or category is young, and then between 20 to 50 is mid, and or maybe put 60, okay, and above 60 is old. So that's my definition of when I want to convert into categorical. Now I can use this definition. I can simply say he is, the first record is actually mid-aged, second record is also mid-aged, old age, mid-aged, and this is young. And oops, okay. All right. By using that information, this is now mid-age, old age, mid-age, and young age. So now it's an ordinal data because I don't have the values, I just have the category. Are you a young, or you a mid-age person, or you are old age person? So it's a category, and this does have an order. Young is the first one, which is youngest, and then middle age, and then old age. So this is ordinal. So I have converted my discrete data into ordinal. By doing so, I lost more information, isn't it? Almost lost everything. Just I know the category, either the young or old or middle age. The next interesting question, can you also convert this into a nominal value? Nominal does not have an order. Well, answer is yes. Okay. So let's say I'm a gaming company. I'm doing a customer segmentation. All right. So I have different kinds of games. Some games are like arcade games. For example, your Mario, Pac-Man, these are arcade games of games, usually played by smaller, younger kids. It's also interesting that older generation also prefer arcade games, right? But mid-age and people who are more than 20, they might be more playing AI games or more 3D games or high graphical games. Okay, so I have only two groups. Group 1 is actually people who are less than 20 or greater than 60. The rest are actually group 2. Okay, between actually 21 to 59 or maybe 60, because I said greater than, I can actually take 20 as well. So anyone between 20 to 60 actually a group 2. So now I can simply say this is group 2, this is group 2, this is group 2, this is group 1, this is group 2, this is group 1. So now group 1 and group 2 does not have any hierarchy or any order. They are just two different groups, which is categorizing my target customer group. So group 1 is more for arcade games and those kind of things, and group 2 is for more graphical games or artificial intelligence games. So I could even convert the ordinal into nominal by defining certain things like this. And of course, we lost further more information. But the information we have is in a different way. Okay. Great. So you observed that from continuous to nominal, we are losing information. All right. But can I do the otherwise? Can I actually convert a nominal to ordinal to discrete to continuous? Well, it is possible. Let's say you have a dog breed. Let's say dog breeds. We talk about dog breed. I'm not a big dog enthusiastic, though I love dogs. So I'm not very specific. So I know a few things. Husky, looks like a fox kinds. You have pug. You have I don't know, golden retriever, German shepherd, etc., etc. Okay, and this is what kind of data? Two different breeds of dog. It's a nominal data, so it is a nominal data. It doesn't have any order, and it is categorical. Okay, nominal data. If I want to convert them into ordinal data, I need something to order them. Let's say I'm going to attach an attribute. So I'm going to take height as a parameter to order them. Which is the tallest dog? I don't have much idea. So I'm going to say German Shepherd, and then maybe golden retriever. Oh, actually Husky maybe. So if you have, if you are a dog enthusiastic, you know what exactly. If I'm doing wrong, please excuse me. I'm not really good in this. Golden retriever, and then of course pug I know is really small one, so it could be lost. Now I have an order. So this is the tallest dog, this is the shortest dog. I have an order. I've converted into ordinal data. By doing so, I'm adding more information. So when you're going from nominal to ordinal and to discrete to continuous, you're adding more information. It contains more information. Okay, so I hope that is clear enough, and that completes your first one. We'll go to the next module. Thank you for watching this video.